So in this lesson, we'll be going through finding the lesson of a cubic function, and really to find the turning point of a cubic function, what we'll be looking for. If we're given a cubic function that has shape or that form, we'll be calculating point A and really calculating point B. And if it's that shape, we'll be calculating point C, calculating point D. So in essence, to calculate the turning point of a function, for example, f of x in the first question, what we need to know is that we need to find the first derivative of f greater to 0 and solve for the x value. When you find the x value, we need to take the x value, substitute it to the original function, and then this will give us the y value, and in that form we calculate it. The turning point, abbreviated as TP, that will be x is to y, the x being the x value and the y being the y value that we just calculated, and then that's how I calculated the turning point of really a cubic function. So let's apply this knowledge that we learned to this question that we have. It means we're going to really take f of x, we're going to find the first derivative of f of x, which will be negative 3x squared. It's 12x minus 9. We need to equate the derivative to 0, then we solve for x, then we'll find the x value of the turning point. So we do that, equate to 0. This is like a trinomial, so we just divide everything by negative 3. So we have to have a positive x squared, so it will be negative 4x plus 3 is equal to 0. Factors will be negative 3, negative 1 equals to 0, x will be equals to 3, or x will be equals to 1. So what this in essence means is that we found 2 points really for turning point. We found one turning point to have an x value of 3 and the other turning point to have the x value of 1. So we need to find what our corresponding y value is. And to find the corresponding y value, we substitute x is equals to 3, x is equals to 1 into the original equation or the original function. And that will look like f of 3, where there's x, we substitute 3. It's 9, 3 plus 4. And this will give us a value of 4. Punch everything in the calculator, we'll get the value 4. Means that the first turning point is 3 is to 4. Then you do the same thing for 1. And you punch that into the calculator, it's 0. So therefore, our turning points will be 3 is to 4 to 0. So let's move on to the next question and apply the same knowledge. So in question number 2, we need to find the first derivative of g, which will be g prime of x, is equals to 3x squared minus 3. Remember, we equate the first derivative to 0 and we solve for x. So it will be 3x squared minus 3 is equals to 0, which will be 3x squared is equals to 3. Divide both sides by 3, and we'll get 1, and then square with both sides, you're going to get x is equals to negative 1, or x is equals to 1. So therefore, we know that our turning points, so far, one has an x value of negative 1, we don't know what the y value is. The following one has an x value of 1, we don't know what the y value is. So we need to find the y values, turning points, and we find that by substituting these x values, first x value being negative 1 into the original function, cubed minus 3 minus 1 and minus 2. And when you substitute that into your calculator, you should get this will be equals to 0. That will be 3 That will be -3, -3. Yes, that's equals to 0. Then we do the same thing for 1 cubed minus 3, 1 minus 2. And that should give us -5, -4. So we know that for 1, the corresponding value for 1 is -4. And the corresponding value for -1 will be 0. So in that way, we would have calculated our turning points. And we're done with number 2. Now let's move on to number 3. So it's the same principle, same way of thinking. Find the first derivative of k, which will be p prime of x, which will be equals to dx squared 10x minus 8. Equate the first derivative to 0, and you solve for x, dx squared minus 10x minus 8 equals to 0. Then we open two brackets, and we need to find the factors really. So the factors will be dx minus 8 and x plus 1, which means x will be equals to, take the 8 to the other side of the equation, which will be 8/3, the first x value. The next x value will be x is equals to -1, which means our turning points so far are 8/3 and -1 is 2 unknown so far. So we need to find the corresponding y values by substituting into the original, which will be the k of 8/3, 8/3 cubed minus 5, 8/3 squared minus 8, 8/3 plus 12. So if we quickly punch this into the calculator, you get that it's -700/27, which means the corresponding y value here, -700/27. -700/27, and we need to find the corresponding y value for -1. So we substitute -1 into the original. -1 cubed minus 5, -1 squared minus 8, -1 plus 12, and this will give us the answer of 14, which means the corresponding y value for -1 will be 14, and we would have calculated our two turning points. And really, we can use this to sketch the graph with many other points as well. So we would have answered the third and last question, calculating the turning points of a cubic function.